Let's now cover the implementation of semaphores. To implement semaphore, I have divided it in 6 steps to make it easy for you. So follow these 6 steps and you can easily synchronize your code using the semaphores, a semaphore variable. Okay, the first step is include the library semaphore.h. So you don't have to write the functions wait and signal all over again yourself. You just have to call them and they are written in this library semaphore.h. So the first step is include this library semaphore.h. The second step is you have to declare the semaphore variable in a place accessible by all the processes, or if you are performing synchronization between threads, then all the threads. And this is the reason I asked you those 2 questions in the previous video. So you have to do that, and the third step is initialize the variable, the semaphore variable. To do this, we have a function which is known as sem_init. We will see it in detail in the next slide. Okay, after doing that, after all your work is done, at the end of your program, you have to destroy the variable. So actually, this is the these are the steps of your main program, and these 2 are the steps that are done in the processes or the threads. So in the process or in the thread, you have to make sure that wherever you use the critical section, call wait operation before it and call signal operation after it. So the function calls in the library semaphore.h for the wait operation is sem_wait, right? And the function call for signal operation is actually a little bit different. It is sem_post. Now let's discuss this third step. The rest of the steps are easy. We'll see them in the code, but we must see this third step, initialization of the variable semaphore. Let's see that. To initialize, we use this function sem_init. It has 3 parameters. The first parameter is the address of the semaphore variable. So here you can see the data type of semaphore variable is under sem_t. So you will write sem_t, and let's say we call it s. Let's say we call this variable s. So you will pass the address of this variable s to this parameter here. That means you will write it like this: address of s, not x. Address of s, since we have called it s here. Now ignore this for a second. The third parameter is the initialization value of s, that with which value you want to initialize it at first. And we talked about it. We initialize it with 1. We talked about it in the previous videos. So initial value is 1. Now let's come towards this p shared. What is p shared? The value of p shared is 0 if we are performing synchronization between the same process, or in other words, between different threads. So we covered this in the last week, that threads are sub processes or divisions of one process. So if we are performing synchronization between threads, it means we are performing synchronization between one process. And if we are performing synchronization between different processes, the value of p shared is any value other than 0. Also, the function sem_init returns an integer value, and it returns 0 on success and -1 on error. Now let's see some code. Let's see a complete example of synchronization of 2 threads.